Okay, here's another trig integral that's a little bit tricky. Sine of 4x, we're going to integrate sine of 4x times cosine of 3x. So this is not powers of sine and cosine. And what's making this a little bit messy is we don't have the same argument inside sine and cosine. So u substitution isn't going to work, right? If I let u equal sine of 4x, du would be 4 cosine of 4x, and I have cosine of 3x. There's no way I'm going to make that work. So there's a couple ways, there's actually two ways to do this integral, two common ways, I guess. One way is to use a trig identity. This is discussed in the book, and it's a pretty obscure trig identity. And where it comes about, you can memorize it if you're good at memorizing, but if you at least remember the sum and difference identities for sine of a plus b, which is sine a cosine b plus cosine a sine b, and the sine of a minus b is sine a cosine b minus cosine a sine b. If you take those two identities and add them together, then we have the sine of a plus b times the sine of a minus b equals 2, because this would be added together, sine of a cosine of b, these cancel out. So we can find a formula for the sine of a times the cosine of b, where these are two different angles, by just dividing by 2. Okay, so this is one of the identities that they have in the book. And there's another one for, like if you had sine a sine b, or cosine a cosine b, there's other identities which can be found in a similar way. So I want to replace sine of 4x times cosine of 3x, and that would be my a, this would be my b, so that can be expressed as sine of 4x plus 3x, which is 7x, plus sine of 4x minus 3x, which is just sine of x, all divided by 2, which is the same as times 1/2. And there we go. Sine of 7x, that's sine of x divided by 2, which is times 1/2. So it actually makes it a fairly easy integral. If I replace this with that identity, factor out the 1/2, antiderivative of sine of 7x is negative 1/7 cosine of 7x minus cosine of x plus c. Of course, the whole thing's times 1/2. And if you distribute, you can get your final answer there. Okay. So that's probably easier than the next method I'm going to show you, but it does require that you are able to either memorize or derive that identity. Okay, and that's not always so easy in the pressure situation of a test. So there is another way to do this integral using integration by parts. Okay, let me show you that. So sine of 4x times cosine of 3x, here it doesn't really matter so much, but I'm going to just arbitrarily choose u to be sine of 4x, dv to be cosine of 3x. Du is 4 cosine of 4x dx, and the antiderivative for v is 1/3 sine of 3x. So my integral, I have u v minus integral of v times du. I can group the 4 and the 1/3 as 4/3 and factor that out. And notice I have in my integral almost the same thing, just the angles are different now, right? Now I have sine of 3x cosine of 4x. So if I do another integration by parts on this, and what is kind of important here, you do want to, for your u now, since we chose u originally to be sine of 4x, it's not so much the sine, it's the 4x term. I want that to be my u again here. So I want u to be cosine of 4x. And I want my dv to be sine of 3x, just like my dv would involve the 3x term on my original integral. Okay, then I did my du and my v integrate. And if you plug this back in, we still had this first term, that's going to come down minus 4/3, and then we have another uv minus integral of v du. A little bit of housekeeping here. Distribute the 4/3. Looks like you have a -4, a -1/3. That's positive 4/3. But if I take that out, there's already a negative there. And then if I distribute a -4/3, we're right back to positive. 4/3 times 4/3 is 16/9. Okay, and then we've seen this before. The thing to notice now is this integral is the same as the one we started with. So we're going to manipulate this and add 16/9 of that integral to both sides. Think of it as 1 minus 16/9 of the same integral is -7/9 of my integral. Would be left with these two terms. So I just have these two terms, and I would divide by -7/9 or multiply by the reciprocal, which is -9/7. And one thing that's a little concerning perhaps, if I distribute this back in, I get this as my answer. And if you compare it to the answer we got when we used the trig identity, which was right here, that looks nothing like what we get when we do integration by parts. So you have to know that it's okay for your answer not to look the same. These answers can be justified to be equal to each other. So just be aware of that, right? So there's two different ways to integrate the same integral.